Hello. Good morning.
Hello. Not actually morning in Berlin, but
Oh,
anyway, good morning.
gosh, I'm still not fully awake. Good afternoon, Karin. How's it going?
um, well, going great. So yeah, my cats are trying to steal some treats that I have on
Uh,
my
you're trying to
table,
entice
but
them to be good for the recording. That's a-okay. I'm sure you'll be. They're being really good right now, but my birds this morning said we'll be not too loud, but we will not be silenced. So I'm like, okay, I can work with that. Um, yeah. So welcome to everyone else, and it's really great to see everyone kind of commenting where they're watching from. We definitely have folks all over the place today. So really awesome stuff. And for if this is your first time for the Chicago Kotlin user meetup, welcome. I'm so happy to have you here. This has been a different experience in pandemic, but it's something I've come to really enjoy, and it's always kind of a nice chill time. So usually what I like to do is we'll start officially at 9:30, but we always like to get to know a little bit more about the speaker. Karin, where are you speaking from?
so today I'm speaking from Berlin in Germany, where I'm based for like almost 2 years.
Wow. Okay. Fun fact: I might be going to Berlin next month for DroidCon, so
Oh,
that'll be really fun. I've never been. I'll definitely have to ask you for like some recommended places to go to. Yeah. So for folks that are here, we're talking about Arameta today. Arameta is an open source library created by 47 Degrees and maintained by them and Kotlin users like you and Karin. And it's a functional companion to the Kotlin compiler. Karin, is there anything more you'd like to add on to folks? Just like give them a brief introduction about what we're speaking about today.
so we are going to speak about like extending your favorite language because like not everything in your favorite language is perfect, but you can extend it to make it even more perfect.
We
And
love
today
that.
we are going to learn how.
Okay, and that's really exciting. And I actually spent some time working with Arameta, and it's a really cool library. So I'm really excited about this talk. Karin, how did you find Arameta? What is the love story?
That's an interesting question. So I think first time when I heard something about functional Kotlin was on Kotlin Conf in Amsterdam like 3 or 4 years ago. I don't remember. And I was coming from Scala background, and I was thinking, well, there's something functional in Kotlin right now. I shall check it out. But yeah, and then yeah, looking through this library, it was like four parts like optics, core, and such. So, and there was a part meta that I never understood why would I need it. And then one day came and I understood that that I have exactly the use case for it. And yeah, I'm gonna talk about it in my presentation. So why and
Okay, well that's even cooler. We have like a pretty much like a real life what do we call it, like study case. Gosh, it's so early I can't even think of words. But that's so great. We have like a real life use case, and I think there's going to be a lot of value looking more into this. So how long have you been working with Arameta for? I know you've heard about it like a couple of years ago in Amsterdam, and there's been like a whole lot of progress even up to the end of 2019, early 2020.
so I think about half a year. So yeah, sadly only one use case since yeah, it's pretty specific. But yeah.
Yeah, no, it's great because even if you go into one use case, it essentially explains how you could do anything else. So I'm really excited for it. Yeah, if you don't mind, I'm gonna run over some logistics, and we can get into your talk shortly. Does that work for you, Karin?
Sure.
Okay, sounds good. And folks, if you have questions during the presentation, feel free to put them in the chat, and Karin will take a look at the end of the talk. So feel free to ask along as the talk goes along. All right, we'll see you shortly, Karin. All right. Well, folks, we'll be just pulling up some brief logistical items. Here, we'll see if I... Okay. Okay, hopefully everyone can see the screen. I'm just double checking because obviously I can't hear folks. So, okay, we have it up. So, hello everyone. Welcome to the Chicago Kotlin user group. Today's talk is called Extending kotlinx Serialization Functionality with Arrow Meta. You've all met Karin. It's going to be a really cool talk, and can't wait to dive into it. So a little bit more about Chicago Kotlin User Group. We believe in being inclusive. CKUG is an inclusive group, so be curious, ask questions, and avoid assumptions. And, always do everything in your power to continue to grow trust, empathy, and friendship. Do you want to give a talk? I think you should. We've had lots of talks online this year. We have an open CFP year round. If it's not in the description for the YouTube link, I'll be sure to add it to the chat as well. It is open year round. We take first time speakers, we take seasoned speakers, and they've all been excellent talks. So please feel free to make that submission. So it's great because it's a good way to expand your network. It's a safe space to practice talks, and it looks pretty good on a resume. Okay, remember we do have like some areas of community. So on the Kotlin Slack, we reside on the Kotlin channel and also on Twitter for Chicago Kotlin. It's a good way to keep up that way. Okay, so for live interactions, we have the YouTube chat, and if folks wish to follow Karin, I've posted her Twitter username as well as the Twitter name for our Chicago Kotlin account. Okay, that is everything on my side. I'm going to hand it over back to Karin, and without further ado, we'll just get this talk rolling. Let's see. All right. I'm going to hand the floor over to you, Karin. Thank you so much, and good luck.
Thank you. So, hello, everyone. So, it's nice to see you here, or at least thank you for being here today for me. So, today we are going to talk about extending Kotlin serialization functionality with Arrow Meta. So, yeah, let me introduce myself. So, yeah, my name is Karin. I am a senior software engineer, and I have a background in various languages, for example, Kotlin and Scala. And also, I tried them on front end, so like Kotlin.js and Scala.js. Currently, I am living in Berlin for almost 2 years. And yeah, maybe my cats will visit us during this talk or Q&A session. And also, since September, I became a Google developer expert in Kotlin. So let's talk about Arrow. So what are we going to talk about today? So why? Why did we use Arrow Meta? What was our problem? What was our use case? Then what exactly is Arrow Meta? Because most of you probably never heard of it before. Then we are going to do a tiny project. So this will be in a live coding format, and we will run it and take a look how successful we did it, hopefully. So why? So my project was actually a backend project with Ktor as a main framework and Arrow library as a functional programming library. So nothing really special, like no fancy user interfaces, so like just transforming JSONs basically. So, and for that purpose, we took Jackson library. Why? To be honest, I'd say more like it was kind of default framework for our department, and it worked very well for us in the past, so why not take it? And yeah, this worked, but uh, there were some issues or like tiny things that we didn't really like. So because it's maybe not as Kotlin first as we wanted, and uh, we decided one day that we want to have more Kotlin first libraries to avoid, for example, having null issues with wrappers over Java library as we had with Makita Kotlin, which is why we switched to Mock-K. So one day we decided to go to kotlinx serialization. And I'd say it was somewhere hit, but somewhere miss, because yeah, it's Kotlin first, it's supported by JetBrains, so it works perfectly with Kotlin. But the problem was for and also yeah, for sealed classes you don't have any troubles as with Jackson, where you have to write, for example, JSON creator function, and if you have a lot of the sealed classes, it creates a lot of boilerplate. But there were also cons. So not a lot of serializers out of the box. For example, if you're using classes like instant, because Kotlin currently doesn't have a big data and time classes. So I know there are some progress for that, but but it's not enough for us. There are nuances with transients and abstract classes that when you have to deal with problem that a field may not be initialized and you have to handle it somehow. But most important problem for us was no global naming strategy. So when we are talking about naming strategy, so you can remember like camel case when you have like the words glued via a capital letter, or for example, snap case when your words in a variable name are called using underscores. So why is that a problem? Imagine you have different naming conventions in different languages, different frameworks, or different projects, and you have a lot of them across your department, across your company, or across multiple companies, and you have to somehow to parse a JSON with, for example, snake case to camel case in your project. Um, in Jackson, you will use something like a object mapper, so like a transformer for JSONs, and select a naming strategy. For example, in this case, upper snake case, which will handle all the transformations of the names for you automatically. But in Kotlin, there's nothing like that for multiple reasons. So, for example, one of the reasons is if you have different naming strategies across your projects, it's hard to like do Control F and search over your whole Slack or GitHub. Well, in Kotlin, you have to solve such a problem via annotation, serial name. But if you have big data classes, like hundreds of fields in one, and a lot of such of data classes, it may become annoying and, to be honest, sometimes even unreadable. And I was thinking, well, is there any instrument that can help us with this one? And actually there is. It's called ArrowMeta. ArrowMeta is a functional companion to the Kotlin's compiler. So it's a library used for metaprogramming when you're transforming your source code as an input and do fancy stuff with it. So there's a GIF that will explain you the process in brief. So imagine you're writing some code, and then Meta intercepts this code and rewrites it. So then code just compiles, proceeds, and you get the expected result. So sounds pretty simple, isn't it? Well, let's try it. So if you want to follow the finished project, you can use this link that is encoded in this QR code, or you can, just continue watching as we will write it right now. So let's imagine a sample project. Today, we are going to build a zoo with various animals, actually only cats and dogs for the sake of simplicity, from various sources. So imagine them being from various sources and with various standards of documentation. So we want different naming policies for another service. Well, let's do this. So I prepared a sample project for you with two data classes, cat and dog. They're exactly the same, so they have fields name, age, owner name, and breed, and they are serializable using Kotlin serialization. So as you can see, owner name is written in camel case, so exactly as Kotlin guidelines tell us. And if we create a sample cat or a sample dog and encode it to string using Kotlin serialization, we will get exactly the same naming strategy. So owner name is written in camel case. The setting of this project is pretty straightforward. So I'm actually using a bit outdated stuff because I didn't want to update it right before the talk. So I was afraid that something may break, but I don't think it will be a problem actually. So we are using the plugin for serialization and import dependencies, and that's it. So let's think, how can we solve this problem of renaming? For the sake of simplicity, we will say that currently our service supports camel case, and we want to encode the names of our variables to snake case. For that one, I created a project with slightly different setup, but exactly the same main class. So we have cat with name, age, owner name, and breed, and dog with the same fields. So let's get started. So speaking of the setup, actually, you have to set up the project a bit in a tricky way. So now we have, as you can see on the left side, two folders, two directories, create plugin and use plugin. As a sample setup, I used the sample project from Arrow Meta repository, and I can recommend doing the same for your very first project because it may be simpler having the project that is already set up. So the create plugin is not as is so not so special. So as a dependency, you have to add Kotlin and Arrow Meta, and then and then you have to create a job that will wrap your plugin to a jar. It's a pretty standard script, so I won't focus on this one. And in build gradle for use plugin, you have to tell the compiler so that this compile task depends on the plugin compile task. So when you are running your main project, the compiler project will also build and do all the transformations for you. So now we have our cat and dog serializable, and with naming strategy as camel case. So let me think, how could we solve that? So my idea was, if we have a class with serializable annotation, we can grab all the fields of this class and rename them. Or in the terms of Kotlin Serialization, for every field, we could add a serial name annotation with the proper renaming to, in our case, snake case. Well, let's do it. So, okay. Let's start from the scratch, actually. And yeah, so first, to create your plugin, just one second, you have to define it. So let's start with class. For example, let's call it serial name plugin, which extends meta. And import everything that idea suggests us. So now we have to implement members of meta. It's the function intercept. In this function, we will register our plugin logic. So, okay, in this block, we will list the list of our sub plugins, or like all the transformations that we want to do with our source code. So let's call it, I don't know, for example, serial name generator, because we are going to generate a new annotation for every field. So, okay, let's call it like that, serial name generator. And now, let's describe the serial name generator. The plugin that you're creating should be an extension over meta with the exact same name, and the type of it is CLI plugin. For this one, we have to implement getter with where all the magic begins. So let's stop it with to do for now. So how do you describe a compiler plugin? So you have to define a name for this one. Then you're defining the stage of when you are intercepting the code, and how do you transform it. So let's start with the simplest task. So let's call it a serial name plugin. Serial name plugin. And now the magic begins. So we are using the function called method, which has as a parameter a face So as you can see, an extension phase. There are multiple extension phases actually here. So for example, there is class declaration, where the class are defined, like class body, everything that is inside this class. Or there is also, for example, finally section. When you add, so you can also go to the definition of each function, and for some of them also, if you exit the presenter mode, there are examples. So, and looking at those, we can see there are finally, for, function, liter, if expression, but serializable is an annotation that is used on a class. So sounds like we should take as a phase of the transformation class declaration. Now, what do we want to put here? So there is compiler context, there is some predicate, which will tell us should we transform this class or not, and there is the transformation itself. So default context is this, and it stays this way. Some function that will match our class, and some transformation. So let's start with which classes do we want to transform. So as I told you, my idea was let's take all the classes that are annotated with a function, with an annotation. Okay, I guess I have to add some imports here. No. Okay, just 1 second. So class declaration is annotated with. So okay, let's continue for now. Okay. We want to take the functions that are the classes that are annotated with annotation serializable, and we serializable, and yeah, regex, and do some transformation. 1 second. Is annotated with. Okay, I'll take a look on this one a little bit later. Let's talk about how are our classes defined. So a class is defined using annotations, kind of class, name, some type parameters, and body. So for a class declaration, for a class element, so let's write a transformation for this one. So 1 second. Okay, so for a class element, so for every class that has been matched, we are writing some transformation. So how do we define a class declaration? A class is, as I told you, like new declaration, because we are going to work with it, is defined as follows. So for class element, we've got here in backticks annotations. So the old annotations that we've got. So let me clean up this branch because it seems not to be refreshing. And okay, wrong branch then. Okay. Yeah, sorry for the technical issues. Okay. Let's check out to the fuller logic. Huh? Let's try to rebuild it. Maybe it will help. So yeah. Okay, yeah, I think one annotation, one import is actually missing here. Nope. Yeah, just 1 second. Okay, if there, so in the background, let me explain the logic of the code that we should get, because yeah, I guess there is something wrong with the project setup for now, but yeah, let's focus on the things that we want to get. So for the class that are matched for us, I guess experimental contracts are missing. No. So my idea was for the declaration. So we can add it as a string. So when we are rewriting our code, we will pass a block in place of the other ones. So as I told you, a class element has annotations, kind, name, type parameters, some parameter of strings that we will explain later, and body. So for so yeah, give me just 2 minutes. I will open a project that worked for me today, and I think everything will be fine. So serial name plugin. Yeah, perfect. So here, maybe let's focus not on live coding part, but yeah, on what could be written here. So let's get back to the presentation mode. So this one, and to presentation mode. So here, as you can see, there is a parameter list. So we are getting the parameters So first of all, for our class element, what we are going to do is creating a new annotation called serial name. What's important here, as you can see, there is a full name. So at kotlinx.serialization serial name. And this is important because our generated code won't have an access to the imports. So it's really important to put the full name for this annotation. So for every field name, we are taking its name and and transforming it to snake case. So to snake case is actually a function that I took from Stack Overflow because it can be done with regex just fine. But to be honest, I don't really want to write such an regex by myself. So this is working like in human words, like you're splitting your variable name by words, so by capital letter, and yeah, joining to string using the underscore and casting it to lowercase because in our snake case we don't have capital letters. Okay, so the thing is, some fields may already have uh, this annotation, so we should exclude them. So if this a field is annotated with serial name, we just return it as is, so it text. Yeah. And if it's not, we are adding this serial name annotation, renaming it to snake case, and adding the new name and adding the name of this field. Then, since we are doing this on the constructor, we are just collecting them to a string in the parentheses. So just exactly as you would write it in your data class. So for example, so I haven't opened them in this project yet. So as example, our cat and dog class are written exactly this way. So there is a data class and there are constructor parameters written in parentheses using the commas as a separator. So when we are talking about Kotlin serial name, this one. So when we are talking about a transformation, a class is like, you know, a blocks of cubes that you can put together, which is why we just redeclaring our class, like we decomposed it to multiple blocks like annotations, kind, name, time parameters, and replaced it the old parameters with the new parameters that have their new annotations here. And then we are just replacing a previous class declaration with the new one. So we are saying the new declaration and take this class as our scope. So now let's get back to our class and see if this worked out for us. So there is a class cat and dog. This is the wrong project, I guess. No, this is not. Okay. So we have owner name declared in camel case. So let's run it. As we discussed before, when we run our use plugin, we are also are running our create plugin. And as you can see, the field is renamed successfully from camel case to snake case with owner name written with underscore. So this works. Yeah. So since we had some technical issues, I suggest to go to all the questions that may have arisen from this incident and go through the code parts that are unclear together. Yeah, I guess this is the problem with the with the import of the project, because currently it's synchronizing with OneDrive for some reason, and sometimes it leads to the problem like this, and I'm not sure why. Yeah, what's important here actually is arrow meta is still not really production ready, because the API of the Kotlin compiler changes sometimes. And yeah, there may be the issues here. So for example, I didn't use this plugin in production, but I wanted it as a proof of concept. And yeah, as Amanda is mentioning in comments, yeah, there are not a lot of like tutorials yet, so you may run into various issues. And yeah, now we found another one. So a typical question that I've been asked is, are there any alternatives for Kotlin for arrow meta? Well, as I know, there is KSP and Kotlin Poet, so you can process annotations with first one and do some code generation. Uh, I'd say it covers, for example, maybe this topic, but our meta has a wider functionality in theory. So in the library description, there is an option to create, for example, a linter, which I didn't really try it, but sounds like transformation of the source code may lead you to to bigger like options of doing something fancy with your code than just adding it as a code generation. So the question is, what method does in the background does it use reflection for understanding the code best to it? So well, while it looks like reflection, it operates with the with the code blocks itself via the compiler API. So if we go, for example, to the compiler code itself, and go, for example, for class declaration and look inside, there are compiler context and some elements that are um, yeah, already the depths of Kotlin, but they are not arising from reflection. So imagine you are rebuilding the syntax tree of your code. So of course, another solution to this problem may be, for example, if you want to have more flexibility, you can provide a custom annotation or like I don't know, add as a project parameter the type of the um, naming strategy that you want in your current setup and just write another transformation, and yeah, this will work.
That was a really excellent demonstration. Thank you so much, Karin. I know some folks already had some really good questions going on in the chat. I have a couple more myself. So the code itself looks really clean and nice. Have you tried building a compiler plugin for Gradle, like without error meta before? And if you have, how does the experience compare?
Well, to be honest, Gradle still feels for me as a like big magic box, and I haven't tried it yet. So I'd say it was more like I knew about arrow method before, and it just clicked in my head that I just should try it. But no, I don't have any experience with building Gradle plugins.
Yeah, it's not very intuitive. I feel like it's just crazy to see how you could create a compiler plugin with this little code. And yeah, so it like we could maybe like dig into the code a little bit more. I'm just gonna make the screen a little bit bigger because I need glasses. Yeah, so we look into this class declaration. So, you know, for folks that don't know, when you take like a compiler context, you can actually intercept like any phase of the Kotlin compiler. So the class declaration, I believe that's a representation. It's a wrapper for the PSI element for the KT class. Is that correct?
Yeah, and there are actually a lot of them. So there's yeah, for example, binary expression, block expression, there are lots of them. So I guess every phase that you can imagine is here.
Yeah, so it's just really hard to like wrap your mind around the possibility you could intercept and then just like grab literally any part of like the Kotlin code. And it's what's really interesting is that you're detecting like the at serializable and you're changing the namespace for it. Is that correct?
What do you mean by changing the
The
namespace?
Sorry, so like with the serializable, if it's annotated with serializable name, then it
So
looks like, yeah,
it's a predicate that yeah, we are
yeah,
filtering
yeah.
classes by. So yeah, we are just taking the option is annotated with, yeah, serializable. or like any option of serializable. Also, I don't know, we can filter our classes by a lot of stuff. So for example, it's not top level class if we want, is like
Like you only wanted to
pre
get like a nested class or something.
yeah.
So crazy. And then with that, you change like some of the code. Is that correct? If we scroll down a little bit. Uh, yes. So we have the annotations, and then it looks like we do like a kind of create like a we replace the actual text itself before it compiles. So like once the text is changed and you hit compile time, you're intercepting like what it's actually reading, and it'll adjust accordingly.
Hmm.
And
Yeah, and
oh, go ahead.
no, it's like everything except yeah, our params is everything that we had before. So those parts are actually unchanged. So it's a bit of simplification maybe because I was making them for my simple case mostly for data classes. So maybe there is something more, but yeah, this works.
Uh, I don't, I'm a huge believer of simple use cases because I think it just gets right to the point. It explains very clearly what's going on, and it leaves room for us to ask questions like, like what is this synthetic scope? Like, what's the significance of putting that synthetic scope in your transform replace?
Well, it's just the compiled scope. So yeah, it's more
Mhm.
like into details. So it's yeah this. So we have to declare the scope for our replacement, and we just say it like everything that will be compiled. Will
Yeah. So this
yeah
part is more like the just like kind of the work wrapper required for the library itself to do the work it needs
yeah.
to. Yeah.
It's like yeah, not something like special. It's just more standard way you have to do that.
Yeah, I let me check. I feel like I had another question written down somewhere. Oh, I'm not sure if I did now. And folks, if you have any other questions, we have a few more minutes for some additional questions. But yeah, this is awesome. Are you planning on? I know you showed a QR code of the project itself. Would you mind showing that one more time for folks?
Which code?
Oh, did you have a QR code of this particular
Yeah, yeah.
project? Yeah.
Let me.
And I
Um,
suppose I could tweet it out as well.
yeah.
Yeah. Folks, if you're interested in looking at a real working example, here's the QR code for that. So that, I mean, honestly, that's kind of my favorite way to learn new libraries. Take a working example and just build off that. I'm sure lots of people, I'm personally going to star it. I love simple examples. I'm just a huge fan of it. Yeah, no, it's awesome. I think it's just something that you could like, if you could take and create like an internal solution for yourself, or you could create a solution, for other use cases like other libraries, or you can even use it to demonstrate extending like the Kotlin language itself. So lots of great use cases for it. This is a very cool and practical one, and one that we went over in large detail. I think it's very rare to see something like that. So this is truly unique content. And also, oh, I now remember what that question was. let's talk about
Sure.
let's talk about some of the compiling issues that we were having earlier. I know some folks were speculating. I'm just looking back at the notes. Yeah, we have one person, Alexander, said that it looks like the Kotlin PSI classes were not found for some reason. What do you think is going on there? I think like uh, just some personal thoughts of my own. So the thing is, like, Arameta is a library where it's just very low level stuff. It's really like you're hooking into not only the compiler plugins, but sometimes you could be working on IDE plugins as well. Oh my goodness, my birds have decided that they are not going to be quiet anymore. um, yeah, so
Well,
Yeah, what do you think? Is Era Meta still is like kind of in development stages. I'm sure there's like more room for stability, but what do you think like the current issues are with using it, and like where does it need to go from here?
So for this exact problem that we have, I guess, yeah, as I told you, for some reason the project was synchronizing with my cloud, and I think something was wrong with caches of idea, actually.
Oh,
So
classic.
so
Yeah,
yeah, this is why it worked right before our presentation, but not
yeah,
now. So so I'm glad to have a like reserve copy. So for Arrow Meta, so like I want to have more detailed um, documentation, because Arrow Meta is a great framework, but it has also the same problem as Ktor. Like sometimes you're running into an issue and there are no docs on this exact part
yeah.
that
They're
you
really.
need, and then you're
Mhm.
what should I do? I have no idea. And because
Yeah,
it's such an let's say low level, you have to
you
know
have.
a lot.
You do, yeah, and so that's one of the amazing things about Arameta. This is from personal experience. The folks in the Arameta channel are incredibly helpful and knowledgeable, and that's just the reality of like working with open source libraries, especially when they're starting out, right? I mean, it's a few years old and it's definitely gotten more mature, but yeah, I think it's like a general like thing that I wish I had working with my favorite libraries, just kind of like a troubleshooting doc. Like, hey, here are problems we consistently run into, and if there's like recorded documentation of it, like maybe someone can solve it one day. Like at least like create a paper trail or something. So I think this is kind of like cool because this is just like an example of like how we look into how we develop like open source libraries and languages, kind of like the evolution of it. So I think like in a sense, like seeing those compiling issues was really enlightening for a couple different reasons.
Yeah, and yeah, people from the team are really helpful. So when I just started using Arrow
Mhm.
Meta, I couldn't really understand how to set up the project, and it was also before the some changes that were in the library structure, and I just came to the channel and said, "So can someone help me with this one?" And everyone was so nice. So if you need some help with, yeah, just quick starting, yeah, the community is super helpful, can recommend.
Yeah, and that's the Arrow Meta channel on the Kotlin Link Slack. We'll be sure to we'll probably post all these links
Mhm.
in the Meetup channel, maybe as a comment in the YouTube as well. Actually, if you send me the links, I'll be sure to put it in the description as well. Yeah, well, I think that is okay. Let's see. Yeah, we have some really great comments in here and some excitement. I mean, personally, I've been itching to use Arameta for my own use cases as well, and this like renewed that fire for that. So thank you so much, Karin. This was really awesome. And I think we'll leave it off here. But yeah, please feel free to post any external links on the meetup page on YouTube. Send it to me, and I'll be sure to tweet it out. And thank you, folks, for sticking around. This was a really nice meetup, and we'll see you next time. I don't have any meetups lined up after this, but I'm sure it's a matter of looking at the submissions. Oh yeah, and don't forget we have open CFPs year rounds, and like I said, every talk that we've gotten, we've accepted, and they've all been wonderful. So thank you so much, and thank you, Karin. This was awesome.
Thank you.
All
Thanks,
right.
everyone.
All right. See y'all.
See ya.